everybody, those who are joining from India, and also good morning, Castro, and other people who are joining from the West. This is the fourth episode of our Smart Saturday Talk. We started this 2 months back, and we are receiving a very good response. And in this Smart Saturday Talk, what we aim is that we want to bring experts from all over the globe who know about smart manufacturing, who have experience about smart manufacturing, and we want to share their knowledge and their experience with all of you, because smart manufacturing is definitely a way forward. People are there is no choice; you have to do it, but then there is a lot of confusion. There is a lot of you know uh, uh, things which are not clear to many manufacturing companies. How do you prioritize? How do you go about it? So our idea is to bridge this gap of how do you actually adopt smart manufacturing at your workplace. So every year, every week, we identify a few speakers. And this week we have, I think, first time we have an international speaker. Till now, we were all having, speakers from India or Indian origin. But now we have a speaker who has a very vast experience. So let me introduce Mr. Guilherme Castro to he likes to be called as Bill, Bill, Bill. And let
Beleza.
me introduce Bill. He has I met him in my course in smart manufacturing in MIT, USA. So he was my he's my professor, in fact. He was teaching me about smart manufacturing in that course. And after that, we became like more of a friend and colleague. And I'm very happy that he has accepted our invite today to discuss about this. This topic, I think, is very, very important that we are going to discuss today. And I think there is nobody else who can be more eligible than Mr. Bill. So he has been helping manufacturing transformation since 2003, and his experience is spanning in automation, process engineering, lean manufacturing, Six Sigma, MES, and Industry 4.0. Uh, he has worked 4 years in pulp and paper industries, which is kind of a process industries. And then 18 years of his career, he has worked in automotive sector, including one of few of the world's leading companies like Ford Motor Company, Chrysler, and uh, Pirelli. In 2021, he joined MIT Professional Education, and he is a learning facilitator and technical review and subject matter expert and project coordinator for Industry 4.0 courses in MIT. And in 2022, he has founded his own company for consulting, and he is also partner with a company which is a global company called TILLIT. And I think TILLIT has a very, very good platform for MES. So far, all the MES platforms that I have seen, TILLIT is one of the best. And it delivers, TILLIT helps you deliver next generation MES solutions. And he's going to share his experience of TILLIT and working with all these automotive companies in digital transformation. So basically, his focus is to support industrial organization to achieve business objectives through productivity improvement and operational excellence through digital transformation. So thank you, Bill, for accepting this invite, and we are definitely looking forward to learn from you about this topic. You would like to say something in opening remarks, then I can start.
Okay, Nital Neri for the nice words. And Vanakkam, everyone. Vanakkam. I managed to know some words in Tamil when I was working at Ford, and I had some colleagues from Chennai. So it's a pleasure to be here. Uh, you have very nice words. Think about that. Yes, I have been working in the manufacturing since the very beginning. I always work in factories and operations. Um, and I had the luck and the privilege of working in good companies where I could learn a lot in practice. Okay, my first MES implementation, my first SCADA implementation was in 2003. In my first year of work, I was already working with SCADA systems, and my first MES was in 2009 at Ford. Okay, and I could see that happening very close. I mean, um, between 2009 and 2012, we implemented something about around three MES solutions. Okay, each one for to solve a very specific problem. And when I realized I was already doing smart manufacturing since the very beginning. Okay, so that's a little bit of my career. And when I decided to take this program on MIT, okay, to learn more and more, I realized that I wanted to be part of this academic environment and to following this advanced research and application. Okay, and yeah, so nowadays I still work with MIT as a learning facilitator, as a teacher for this online program, and I run my company here in Brazil. Eventually, we have customers abroad, outside our regional market, and yes, we are building a small team of consultants, of senior consultants, to address these problems and help industry to implement smart manufacturing and get value from it. So, uh, thank you very much for the nice words. Having said that, I'm good to start.
Yeah, okay, thank you. Maybe if you want to share your screen, it's okay. And I would like to ask you a few first question
Okay.
about what do you think about. So first of all, if you can just also explain us about what historically has been done, and maybe also before you take your first slide, you can also explain these acronyms to everybody: MOM, MES, and QMS. Maybe everybody is aware, but at least MOM and MES you can explain in a simple manner, and how historically it was being done actually.
Yeah. Well, MES, QMS, and other solutions that we know we may have in a factory, they they were developed since the very beginning to resolve a very specific problem. Okay, so QMS is for quality, to manage quality of a very specific process. Okay, and we have several solutions in the market. Eventually, companies they develop their own solution in house because they have a very specific process and they want to control the quality uh, of their process in the way that they do. Okay, so KMS is essentially a solution to manage quality. Okay, and MES is a solution that was developed to deliver OE, or at least downtime. Okay, and we can discuss it deeper later. But I mean, there is a difference between downtime recording and OE, and I will keep this difference for the final slide. Okay, but most of the solutions that we call MES nowadays, they are very good in reporting downtime events in a machine. Okay, so you may know when the machine stop and why the machine is stopped. Okay, so that's the main purpose of MES solution. And MES means manufacturing execution system. Okay, so with time, these solutions start to evolve. Okay, and these gaps that each solution had, they start to be clear to everyone. And then we came with a more uh, uh, broader solution that's called MOM, okay, Manufacturing Operation Management, okay, and MOM was supposed to connect uh, QMS and MES and eventually other solutions as well. So MOM is a solution that should be managing the entire workflow of an operation from end to end. Okay, so that's the main definition and the main purpose of each solutions. QMS for quality, MES for downtime recording, and eventually OEE, and MON to manage the entire workflow. Okay.
Okay. Okay. Yeah, that's where that clarifies, because for many participants it may be like MEM and MES and MOM is the same thing, but I think you clarified it very well. The downtime
Yeah.
reporting is about MES, and then complete operation management will be under MOM.
Yeah.
So can you tell us how historically this was being done in the factories, and what was happening right now in MES, MOM, QMS? How people were managing all these things in traditional manner?
Yeah. Well, we have a couple of things that we should consider when we think about the history of and the evolution of each solution. Okay, but a core aspect of every solution that we still have is that they were developed and implemented in silos. Okay, so each department they had a very specific problem. Okay, and they develop a very specific solution to address that problem. Okay, and I, I felt that at Ford. Okay, so we had a very robust and detailed solution for quality, but that solution was completely blind for tool management. And the tool life and the tooling itself is very important for quality. But if I wanted to know which tool I was using, I need to see in another solution, another platform with many screens, with a lot of information about the tooling. And that solution had no information about the equipment. So then I need to go to another solution that was telling me what was running in that equipment, what was the production and the downtime recording and the alarms in the machines and the event. But if I wanted to see the CNC program that I was running that moment, I need to go to a fourth solution. So if I wanted to run a deeper investigation where I wanted to see feeds and speeds, alarms in the PLC, uh, the details about the tooling itself, and the quality I got, I had to get data from 4 different solutions. And they are very good solution, but they are very specific to address they're very specific to address the problem that they were designed for. So when I wanted to run a process investigation about quality or any improvement or just to track and trace what happened in the shop floor, it was a massive work, massive work. So every solution was developed in silos, okay, and eventually, or very often, they were developed by a very specific department. So during many years, MES was an issue was a project that belonged to IT departments, but IT departments doesn't have the pain. Okay, the pain belongs to the manufacturing. The pain belongs to the process, to the operation. And the IT guys were developing and installing a solution that they had no idea how that worked in the real life. So that's still a reality, and we still see that happening nowadays with AI. So many CEOs and many directors they address AI projects to IT departments, but it happened that the IT departments they have no idea how to do that. That's not their expertise. Okay, IT is a very vast, very wide field of knowledge nowadays. So when we do that, we eventually have a solution that is technically correct, but is not usable or easy, not usable or not friendly and not accessible for most of the people. Okay, so that's also another issue we see. So QMS, MES, MON, they were born, they evolve in this environment where We have silos everywhere. We have very specific departments performing or developing their projects. Okay, without a broader view of the business or a broader view of the process. So eventually we ended with solutions that were very technical, very hard to manage. Okay, and also thinking about technology. Okay, these solutions were developed with the technology and the resources we had available at that time. Okay, so we started with SCADA systems, so collecting data from sensors. Eventually, in a future moment, we have a MES solution, and this MES solution was connecting one piece of equipment with a solution like ERP, and then we started to have some context to the signals, but that was still very limited to a very specific equipment. And with the evolve of time, we started to add more and more signals coming from different equipment, from IoT sensors, from other systems that were already running. And so, I mean, each solution evolve with the data they have available by each in the time it was developed. And some solutions evolve faster, other still relying on an old database, and I mean, eventually it's very hard to change this data architecture. But that was the environment that every solution were developed with limited resources of data and technology in silos and developed by very specific teams.
Yeah. So I think in your presentation also you mentioned that still in most of the companies they rely on spreadsheets, paper, phone calls, manual reporting, load traceability, and
Yeah,
all that stuff, you know. So that is the reality still. Now
yes,
I
that's the
I
reality still.
I like one particular slide which you had shared with me. Maybe I can bring it on the screen also for
Sure.
everybody. And that is very interesting. And you can explain us about what do you mean by machine centric to human centric? You
Yeah.
know, this workflow centric actually. So this particular slide, yeah. If you can just
Yes.
explain us, yeah.
Okay. I will ask you to go to the ISA 95 slide where we
Yeah,
have the.
yeah,
I
okay.
believe we can start from there.
Yeah,
ISA. I believe you should go down. No, sorry. Oh, go up. Yes, that's the one. So
yeah,
as you can see, we have a global standard that's called ISA 95, and this ISA 95 defines the global architecture of industry running aligned with the best practices of smart manufacturing. So we have five levels of automation. Okay, starting from sensors on level 0. Okay, going to PLC and I/O connections or controllers on level 1, and then we have SCADA and HMI, and then on level 3 we have the systems like MES, MOM, and QMS. Okay, and the fourth level, the final level, is the ERP. Okay, so that's the global architecture, how the data is flowing from the planning, from the strategic until the shop floor. Okay, that's a very well-known figure. Okay, and from level 0 to level 4, we can think about all sort of data we have available nowadays. Okay, and the thing is, even the most advanced company you may think, I mean, even a dark room, a factory that is running with dark lights, and fully automated. Okay, even this factory has a maintenance guy. Okay, and the maintenance guy must do a maintenance task like a preventive checklist or so on. Okay,
Correct.
and happen that in the end of the day, this maintenance operator is running is performing his work and taking notes on a piece of paper. Okay, that's the reality of most of the companies. Okay, and in the end of the day, the maintenance manager, must guarantee that the maintenance guy actually perform every preventive task he had to, or so in the end of the day, the maintenance manager of this highly advanced manufacturing plant with no operator has a pile of paper on his desk. And if he wants to see what's happening in the factory or regarding maintenance, he must compile all that information into a spreadsheet or a BI, and then he will realize what happened in that day. Okay, so that's a very didactic story, but that's true in most of the cases. I mean, we are still. I mean, we can look into this architecture, okay, and see that there's no reference to human. Okay,
Yeah.
and human is still very important in every operation, even in a very advanced factory with no operators. We still have a maintenance guy.
Yeah.
And the machine will never know if the maintenance was done on herself,
Yeah.
on itself. We
Yeah.
need a human to do that. Okay, at least yet. Okay, uh, so how can we guarantee that the maintenance actually happen? We are making records on a piece of paper. That's the reality of most of the process. So
Correct.
if we want to control the quality, we ask the operator to fill a checklist. If we want to control the safety, we ask the operator to control another checklist. If we want to control the setup, we ask the operator to fill another checklist. So in the end of the day, the operator is filling a lot of paper. Okay, uh, we we play a joke here in Brazil that the operator seems to be working in a notary house. Okay, with paper everywhere in an office. So we have a lot of
Yes.
paper everywhere
Yeah.
because, especially here in Brazil, where we have very rigid labor laws, so we need to provide a lot of evidence to the government about safety, about cleaning, about best practices, about ergonomics, and so on. So we need to provide a lot. We need to keep records of everything, and
Yeah.
that's not adding value to my process, but that's mandatory. That's a law requirement. So the operator is taking notes of a lot of things, and we need to manage this information later. Okay,
Correct.
so there is a final layer of information that is not mentioned even nowadays. Even nowadays, it's not mentioned on ISO 95. It's not mentioned in any MES or QMS system or MON system. Okay, that is the information that is managed by the operator. Okay, so we have this standard checklists. Okay, even TPM. Okay, if you think about TPM or autonomous maintenance, we have a checklist that the operator must do daily to find and report abnormalities, and that's always managed on paper. Okay, so
Yes.
this final layer of information is not even mentioned by the international standards yet.
Correct. Correct.
So and that's the gap that we think is very important, because this information is very important. Okay, and in many cases, these informations are very hard to sense with a sensor. Okay, it's very hard to
Correct.
measure with a sensor. So we still have this tribal knowledge. I mean, the knowledge of the operator that is running that process every day, is operating that machine, and he understands what's happening, and eventually something is not under control. The operator can perceive it. Okay, and then how we are reporting that on a piece of paper. So that's the gap we see.
Yeah.
Okay, and eventually we are reporting this in a spreadsheet or in a tablet or even in a system. Okay, but what I have seen so far, okay, are systems that are not smart or not friendly. Okay, and what I mean with not smart and not friendly. Well, not friendly is when a system is very hard to use for the operator, and we have many screens to navigate and many fields to fill, and then the operator works for the system, okay, and is not friendly at all. So he needs to spend time on the system, and so that's a very serious problem because the operator must understand the system, and the system must help him, not the other way around. So when we talk about human-centric approach, we are thinking about the operator. Okay, so the operator must be comfortable with the system, and in many cases, just to make a parallel, this operator has a WhatsApp in his personal life. He has a Instagram or TikTok account. He's ordering food. He's ordering food on an app. He has a bank app. So this guy is already connected with the technology in his personal life.
Yeah.
Okay, and but when he goes to a factory, he receives a piece of paper and a pen as a working tool. So there's a big disconnection between what this operator is doing in his personal life and what he's doing on the work. Okay,
Yeah. Yeah.
and
Completely agree.
and all the apps that he knows uh, from Amazon, from Shopee, from the bank apps, they are very friendly. They are very easy to
Easy.
use. Okay,
Easy to use. Yeah.
okay, but whenever he goes to a factory, first, he works with a piece of paper, or if he has a solution, he has a solution that's very complex, very hard to use with an old-fashioned style. So that's what we call user-friendly. So the solutions for the operator must be user-friendly. And the other point I mentioned was about human-centric. I mean, and oh, sorry. The other point I mentioned was that some solutions are not smart. Okay, so let's think that we now have a solution that is well designed, is easy to use. Okay, but now need to bring in is intelligence to the solution. And what I mean with that, uh, we need to effectively, the solution must effectively help the operator to make decisions and to remember him he what he has to do. Okay,
Correct.
so the solution we work, that Stility, is a solution that is uh, workflow driven and is based on events. So every event in a factory may trigger a task to someone. So let's think. When we start the production of the order, we have to do the quality check. And eventually, in the end of the order, we need to clean the machine. Or we need to make a check every 20 hours, and so on. So I mean, we can think about signals coming from a machine, or signals coming from a sensor, or signals coming from an ERP, and these signals are triggering a task, an action to someone, to a quality man, to a maintenance people, to the operator. And then when we have this task being triggered by signals, we start to orchestrate the factory. Okay, and that's
Yeah.
what we mean by workflow driven. So in the end of the day, the experience of the operator or the maintenance guy or the quality inspector working with a solution like Tility is similar to a driver that is driving with a Google Maps or driving with a Waze solution, okay? Because the system is telling the guy, do that now, do that later, that this task here has a higher priority, so that's the what we call a smart system. So
So it's the
the
workflow
operator,
and decision making both are included. Yeah.
yeah. So in the end of the day, what we have is a very quick adoption because the system is easy to use, require minor navigation, eventually no navigation. Okay, so everything that the operator must do is popping up to him in the main screen, in the only screen that he
So
has.
it's like this that when I come to the factory every day, I know what I have to do, and it tells
Yes,
me if I'm doing something, then it tells me you are supposed to do, and this is the priority, and these are the tasks that you have to do. And then
yes,
I can also on a real-time basis see my progress as well as my entire team's progress and the company's progress,
yes.
right?
That's it.
Yeah.
That's
Okay.
that's the point.
Yeah.
So and that's for the operator's perspective. I mean, he has a solution that is friendly, and the solution effectively helps him. But the manager that was with a pile of paper in his desk before, now he has everything with dashboards and KPIs and so on. So, I mean, it's a win-win solution. It's good for the operator and good for the manager, so it's friendly for every level of user. And that's what we believe. I mean, when we have a modern a modern solution that is able to model the process from end to end, okay. I mean, we can model every process or every task in an operation, okay, and everyone likes it because it's friendly and easy to use, and the system effectively help people to make decision and avoid mistakes because we can bring when we have a smart checklist, we can have pokayoke inside the checklist, we can have uh, visual ads inside this checklist, and everything is connected with the machines because we are reading signals from the PLC, so we can see OEE, and so we can see the quality, performance, and we can see every metric, everything connected in one single place. So that's what we believe nowadays.
Yeah. So I think that's very important because rather than managing too many different softwares and too many different systems, you just manage one system, which is like platform as a rather than a it is like a platform rather than a software, right? And then
Yes, yes,
so like you were mentioning in the beginning that when you want to manage a QMS, you have one application. When you want to know about the tools, you manage another application. You want to know what is the program in the machine, then you have to go to another system. And when you want to see the orders, then you have to go to another system. So rather than switching between the different systems and still you are wasting the time, what you're saying is that there is only one particular platform at the shop floor level, which integrates everything together in just one platform, is connected to everything. So it is easy for you to trace and it is easy for you to manage all the transactions. So my next question is, what do you think? I think you have given us a very well idea when in the uh, course also in MIT, why these industry projects fail. Most of the industry projects fail. What do you so maybe you can just give some idea on that. What are the main
yeah,
reasons for these failures?
yeah. What we see here is that still nowadays many projects underperform because digital transformation uh, is often treated as a technology project instead of a operational transformation project. I
Correct.
mean, it's much more than just resources and signals and technology. We must be ready for that. I mean, people must be prepared, and the project must resolve a very specific goal. I mean, uh, technology is a tool, is a powerful tool to solve problems, but that's not an end in itself. Okay, so we see many companies nowadays saying that, oh, I want to have AI in my business, but the question is why? What problem do you want to address with AI? So start with the problem definition. Okay, so as a lean manufacturing guy, I and a Six Sigma guy, start with the problem statement and the problem definition. And once we have that very clear, we are going to find the right solution for that. Okay, so many companies they treat this as a technology project instead of a transformation project. Okay, so they fail to involve the right people, and they fail to define the problem. Okay, so they start with the solution instead of starting with the problem definition. And as we know from Lean Six Sigma, that's not the right way to do it. So that's one of my views. Okay, and on top of that, I also can mention that whenever we are mapping the problems, we need to understand the workflows. I mean, the operational workflows. Okay, and these must be considered. So if we have a solution that is very reliable, but in the end we are still working with a paper, with a piece of paper in the shop floor to gather information, or any kind of informal communication like WhatsApp or spreadsheets. So if we fail to map these workflows, the solution will not succeed. Okay, so that's very important. Another point is the process adherence. Okay, so that's one of the most underestimated manufacturing problems. I mean, we have the documentation, the SOPs, the standards, the control plans, and so on. Okay, but we often lack visibility into whether this process is actually being followed or not. Okay, so when I was working in the industry, I was in my bedroom trying to sleep, and I was thinking if the operator was doing the right thing or not right now. Okay, so we had no visibility about the process adherence. So, and process adherence is very important. So again, as a Lean Six Sigma man, I need to control the inputs. So if I'm doing a good preventive, I should expect a good uptime. If I'm doing all the quality checklists, I should expect a good quality performance. But if not, I should expect a bad result. So if I control inputs, I will have a good outcome. If not, I may fail. Other point that we also should consider is the human behavior. I mean, manufacturing is still deeply human-driven. Okay, so operators make decisions, they adapt workflows, they solve problems, and they respond to this variability. Okay, that is happening every day. Okay, so and many systems they were designed around machines, about transactions, they were designed about databases instead of human behavior. So we need to consider human behavior when we are developing a Industry 4.0 project. Okay. And well, I mentioned already the frontline execution. I mean, we need to be able to have a solution that is effectively helping the people, not the other way around. So the solution must be helpful. They must be friendly, must be usable, and so on. Okay, and later, okay, as a final bullet here, I would mention that the solution should be easy to maintain and to continuously evolve. Okay, so if the solution is rigid, is not able to adjust to the change in the process, is not able to continuously improve itself, eventually the solution may be discontinued. So it's important to have a solution that is evolving as fast as the process. Okay. So just to summarize, the missing layer in many projects is the operational execution. Okay. So that's my view. Hi.
Hello, sir. Yeah, we can hear you. We can hear you.
Okay. So
Nital sir, you are on mute.
Oh, sorry. Yeah, my mistake. Am I audible now?
yeah, I can hear you.
Yeah, okay.
Yes.
So I think you summarized very well about the six things, operational workflows, and this we have seen in most of the companies. Workflows are either not defined. If they are defined, they are not being followed. And then there is like human behavior issues in terms of how do they engage with this new system and processes. And that will happen because recently I visited one factory in Africa. We have seen this. This was a chemical company. Have developed in-house batch management system, a software. But the system was so cumbersome that they had given tablets to all the operators, but it was not possible for operators to fill that particular system. The user experience was not good. So I totally agree with this because it was that digital system was also having a lot of duplication. You enter the same thing in ERP, then you come back and you enter the same thing in the batch management system, and then people started slowly gradually ignoring that particular system only because the user experience was not good.
Yeah.
And frontline execution, I think, yes, very, very important because uh, as we say in the lean, that the value added is on the shop floor, and this frontline people are the people who add the value. So how do we make the life easy for them is very, very important. And yes, what we mentioned last, that maintenance in terms of how do you sustain and continuously improve the system. So I think that is really, really very important. Would you like to share some case study which some real use cases on this? If you
Uh,
can just share
yes,
some ideas about this, and maybe I can share the slide right now,
yes,
and you can
please,
explain us
Anita.
about this.
Yeah, I brought here four cases that I remember, but during this conversation, I just remember another final case that I can start with him. So um, happened that we had a factory that was being managed on paper, okay, and that's not on this. I'll start, and then we installed this solution, the Tillit solution that we work with, and the first result of Tillit was that every metric in the factory got worse. So the plant manager came to us, okay, what we are worse now. No, you're not worse. Now you are seeing what you never saw before.
Reality.
So
Yeah.
the manager was being tricked by the paper, maybe because everyone was faking a reporting in several levels, and the manager had no visibility of what's happening. So he got surprised because every metric, maintenance, quality, in production, every metric got worse. So let's see that as opportunity. Now that we have
Yes.
problems, we know we know where to address it. So once, I mean, the first impression was negative because he was feeling bad about the metrics, and then he realized that he had a huge opportunity, and with a couple of months of work, he then he started to grow and see the results in finance. I mean, but uh, that's one thing that is very very common to us. I mean, the first impression we have is that uh, we are getting worse, and other thing is that we start to feel that people is not following the procedure. Okay, but that was happened before, but the manager had no visibility. So now we are showing him that a very specific task is not happening, or this preventive task is not happening. We don't know why, but we're telling to the manager. And then eventually, when we go to the shop floor and run a Gamba to see, okay, let's try to understand why the operator is not doing that. When we try to do everything that is written in the paper, we realize that that task was impossible because of the time, because of cycle time, because of the resources. So the operator never did that, never. But for some reason, all the reports were good. Okay. And then when we shift to a digital solution like Tility, the operator is not able to fake it anymore. So we start to see the problems. The problems that were hidden in a very specific layer in the human nature. Okay. So that's one case that is very common to us. Okay, so can you share the screen, Nital? I think the first case is the OE case.
Yeah. Can you see the screen?
Yes, that's the one. So
Yeah.
that's something that is very, very typical. I mean, we have a dashboard showing a final OEE of 78%, okay? And everything looks good. But when we go deep, if you please push enter so we can see the next. No. Okay, sorry. I I have to share it myself because we have the PDF version.
Okay, no problem. You can share.
Let me share here.
Yeah, no problem.
I have an animation there. Okay, let me share. Yes, that's it. Okay, so we have this dashboard here showing OEE of 78%. Okay, and the question is, where should we improve? Okay, what's not actually running good here, running well? So when we go to the details of this OEE, okay, we can see that we have different products with different cycle times. Okay, we have different performance. So we have a different availability for each product, and that's all in the same process, all in the same equipment. A different performance regarding cycle time, and also a different quality. Okay, so whenever we see a OEE, okay, in a dashboard, this OEE is very often an average value. Okay, and this average value is hidden a lot of details about the process. So the point here is that in the way we see, OEE should be treated as an attribute of an order. Okay, if I change the order, if I change the product, I need to have a different OEE. So once we are able to manage the order and manage the OEE in the level or in the order level, okay, we are able to see the problems that we never seen before. So that's one interesting feature that we have on Tility, that we are managing OEE not in an asset level, but we are managing OEE in the order level, and then we can see everything. Okay.
Every order you see the OEE.
Oh, yeah, in the order by order, and that's very interesting because now we can see things that are just hidden. Okay, just hidden. And as we know, OEE is also limit because OEE show us availability, performance, and quality. Okay, but OEE has no context of the product. I mean, I have no idea if I'm doing the right product or in the right time or in the right sequence. Okay, so I think I have one more case here. Let me just scroll down. Yeah, that's the one. So that's also regarding OEE and orders. Suppose we have this planned production scenario here with 3 products, A, B, and C. Okay, so that's what the planning department plan for the operation, but eventually operators and supervisors they decide to change the sequence of the orders, and then that's what effectively happened. So the factory produce a different quantity and a different sequence of the orders, and now we have our customer complaining because their product is delayed or is late. Okay, but every metric regarding OEE is perfect. So that's again something that's very, very usual. Okay, that's very common in many factories. The operation decides to change the orders. They have a very good performance regarding OEE, and the planning guy is furious because he has no product to deliver to the customer. So
This is interesting.
So OEE is a very good metric to manage the asset performance, okay? But we know OEE has some limitations. And again,
Yes.
with a solution like Tility, we can effectively manage if the plant is producing the order that was planned. Okay, so as we are managing everything in the order level, okay, we can see, okay, how many products you've done of this order, this very specific order. Okay, and that's very powerful too. Okay, so if you have a MES solution that is delivering OEE to you, but the solution has no context of the orders that were planned, you are being tricked by your own
Yes.
MES. Okay,
Correct.
so that's two cases regarding OEE and planned orders. We also have that's also another case that I faced with a big customer of mine. Okay, they were launching a new product. Okay, and during this launching phase, they had to make several changes in the process, change the parameters, and change the control limits. So, and that was happening along 3-4 months of launching. Okay, so they were doing trials in the shop floor and adjustments and so on, and everything was very dynamic. Okay, but the QMS system was managed by a third-party contractor. It was a very heavy-coded system with many screens of configurations, a very heavy system. Okay, and every change in the system needed to be validated by the global IT department. So the thing is, it was so complex to change the QMS that the operation decided to return to work with paper. Okay, because every change in the QMS would take months to happen and to be validated and to be released. And then the factory had a very expensive QMS system. But during the launch phase, which is one of the most critical phase of any product, they were relying on paper. Okay, so that's again another case that's very interesting, and it's a kind of a pointless because they've done a massive investment on this QMS to support this new launching, and during the moment that was most critical moment, the launching phase, the QMS failed to support the operation. Okay, and that's because of the difficult to manage the system, to keep the system live, and to keep the system up to date. Okay, and then we also have the final case here, where again a factory invested heavily in technology, in MES and QMS solution. They bought a very expensive system. Okay, but part of the process was not covered by the MES because I mean the process was very specific, very particular in a very specific part of the process, and the MES and the QMS, they failed to model that and to cover that process. So this very specific part was launched, was kept with paper, okay, since the very beginning, okay. And also, an additional problem was that the system was very hard to use, very complex, with different screens and non-intuitive. So initially, the system was launched was partially launched. Okay, so most of the operators were using the system, but that part that was not covered by the MES was kept on paper. Okay, and eventually this paper form started to reappear with handwritten notes and so on. Okay, and as the system was hard to use, uh, uh, daily the operators started to return to paper and abandon the system. So again, if the system is not friendly, if the system is not helping the operator, is not intuitive, the operators will gradually abandoning the system, and you're going to waste your money. So I saw that happen, and that's very frustrating for everyone. Okay, uh, and in this case here, this discussion ended between HR and union. So a technology solution that failed in a discussion between HR and union because no one wanted to use the system. So that's what we face eventually. And those are the cases that I wanted to mention today here,
Yeah.
Nital.
Yeah, and you can just tell us about this modern manufacturing
Yeah.
architecture. Yeah,
So just to summarize, I mean, uh, I listed here a couple of attributes or features that we are looking in a modern digital operation architecture. Okay, so as I mentioned, it should be a production order management feature, workflow orchestration, event-driven operations, and with contextualized data. Okay, connecting people and synchronizing operation. We should have a full coverage with end-to-end visibility, and the solution should be dynamic. I mean, we should be able to be continuously evolving along the life cycle. It should be hardware agnostic. I mean, we should be able to connect with different hardware and talk with different industrial protocols, API ready. I mean, open to connect with many softwares. Also AI ready, and that's we haven't talked about AI here, but that's another feature that we are looking for in any modern digital operation. And uh, whenever possible, we should have the BI inside the solution because that help us to do everything faster. I mean, we make an adjustment in the system, we already see the outcome in the BI. So uh, it's very uh, powerful when we are doing this fine tuning, this configuration, when you can adjust the solution and see the dashboard side by side. So if your solution already has a BI embedded, I mean, inside it, that's also helpful.
yeah.
Okay.
So what do you recommend as a kind of a benchmark for this kind of
Yeah.
MES MOM? So I mean, can you just yeah,
Yeah. Uh, as I mentioned, we mentioned before, I mean, we work with Tility, which is this modern platform solution. We have many features. We haven't talked here, but Tility has APS for scheduling. We have material movement models uh, uh, for working process management. They will now launch a WMS solution as well. So everything all together in the same place. We already have AI running inside Tility, and we have AI running two levels. we have AI support in the configuration, and we also have AI supporting the frontline, the front end user. I mean, with prescriptive analysis and also troubleshooting. So it's a really, really interesting platform that I strongly recommend everyone to know, because I mean they deliver a very high value for a minor investment and in a very fast approach. I mean, it's a really agile solution that is able to start small and grow on demand. And as we mentioned, it's an end-to-end solution that can cover every aspect of your production, from the material receiving to quality inspection to maintenance to safety audits and final shipment.
Okay.
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 Nital, I also add here a couple of extra content. I'll not go through it, but we can share this material with everyone. So here we have a timeline showing the evolution of quality management, the industrial mindset, IT and OT side by side. Okay, so that's very interesting to follow, and this will help understand how we are nowadays. And we also have this comparison between ISA 95, MES, and QMS. Okay, so you can go in details to see what is defined or what's the purpose of each solution or standard. Okay, and again, we can see that we have very few reference about the operators and the humans here. Okay. And yes, this additional material is interesting, and we can share this with everyone.
Okay, sure, definitely. Thank you. I think it was great. I personally like few things. One is about the OE that you mentioned. That even though your OE, how do you, when you average the OEs, it shows you very good picture. But when you look at a order level or at a product level, then there is a different picture, and it gives you a lot of other insights. Then the second thing I liked was about even though your OE is good, like 91%, but you are not still your customer will be unhappy because you are not following the order sequence. And I like your practical experience about how when you don't include the humans, and then people start resisting this, and then you mentioned like even union has to intervene in the process of the technology and all that. So some few very good interesting case studies that you shared with us, and you lastly showed us, rather than managing different systems and processes, you manage one platform like Delete, which is a kind of a benchmark that you are recommending. So now what I will do is I'm just allowing all the participants to unmute themselves, and if they can ask any questions specific to manufacturing execution system or manufacturing operation systems, or if anyone wants to ask questions, please feel free. Yeah, Pratyek, go ahead.
Hello, everyone. Hello, there, sir. How are you? It's really so nice to meet you, to hear from you. It's really, really great to have you here sharing your insights. I'm really stoked. It was a wonderful session. So I'm just going to grab this opportunity to have, I have more than one question, so if it's okay with you, and I'll just have the two questions out here, and then you can just respond to it as per your preference. So first is I wanted to also MES, MOM, and QMS. Right? So I've heard about MES, and I've heard about, of course, QMS. These aren't new technologies or, acronyms, but MOM is something I haven't heard before. So is that a different software platform or a different system that is there, or is it the same as, it's coupled with MES and it's a part of MES, because MES is this broader umbrella of management that connects IT with the OT and the IS-95 architecture. But yeah, so that's one. And then the second is, so you mentioned about the only 10% of the manufacturing industries in the US have like one robot, right? And then we kind of see the stat in China where they're the most dark factories there ever, where there is the robot density is, well above 200 or 300 even in Singapore, Taiwan. So the so the intelligence that comes out of this data is then the cost is not a factor. I mean, if you're a big player, if you're an MNC, if a big manufacturing, you can invest, but there are other challenges that come with it. That goes to show okay, automation is okay, it's investable. But for small players, which constitutes a majority of any national industry, uh, you really have to make a choice between trying to go for either you already have a requirement that you want to address, a challenge that is in your process or production processes already. So you might want to go for uh, hard automation, but slowly and in a phased way, or then soft automation, again in a slowly in a phased way, or do they first try to understand the operator behavior, the human part of the production, and then address that by investing in a kind of a MES first? So I mean, which side should they go? Should they have the automation pieces in place before they can connect it with MES, or should they have the MES architecture in place before they can add this hard automation phases to it? So yeah, those are my two questions. Thank you again.
Thank you, Proyat. So, well, the first question is regarding the difference between MOM, MES, and QMS. MOM is supposed to be, yeah.
Nothing. Please go ahead. Sorry.
Okay, so MOM supposed to be the combination or the unification between MES, QMS, eventually your maintenance solution. So when you start to combine all the solution and you are able to manage the entire workflow, you are this is the purpose of the MOM. Okay, so MOM. If you think about lean manufacturing, MOM is driven by workflow, okay, or supposed to be driven by workflow, not just a very specific process or a very specific equipment. So if you think about the losses of the OEE, okay, we have availability, quality, and performance that is driven by the asset, by the equipment. But we think about the losses in lean manufacturing, we have 8 big losses, like over processing or waiting or inventory. So these losses are not shown on the MES level; they are shown in the workflow level. So the MON is a system to support the workflow, to manage the workflow digitally. Okay, not in the equipment level. So so the purpose of developing a MOM was to unify all the other solutions in the shop floor, like QMS and MES, and eventually other solutions, and also address or digitalize the workflow.
Like you said,
Okay.
like for example, the TPM checklist. So if you are doing autonomous maintenance, how do you manage those CLTI checklists, for example? So that CLTI checklist, your MES will not take care of. But when you talk about MOM, then MOM will take care of that autonomous maintenance digitalization also. Right?
Yes. Yes,
Yeah.
yes, that's it.
Okay.
And the cases that we have just seen here, I mean, MOM is supposed to address the orders. Okay, so in the MOM we know which orders I should make, and on
Yes.
the MES I don't know which orders I'm making. So we can have a case with a good OEE and a bad sequence of orders or a wrong amount of delivery. So
Yeah.
MES is blind to the context of the planning orders, okay?
Mm.
And MES and MOM is supposed to understand the orders planned and the order and to manage the order progress, okay?
Correct.
So that was
Thank
the
you.
first question, and the second question. Well, that's a very hard question to answer because every company has their own uh, scenarios with their own problems. But uh, I, what I would say is, I mean, technology is a tool. Okay, it's a tool to address a problem. So we start with lean manufacturing. Okay, what's the problem? What's the bottleneck? What's the critical operation? And we address that problem. Okay, and once
Right.
we solve that problem, we go next step. And so that should be the primary mindset. Okay, and then eventually, if you have a problem of capacity, okay, you may need to have a faster equipment, maybe an automation, a hard automation with a robot or any kind of equipment. So that's one kind of issue. But eventually, yeah, and that's true in most of the cases, okay, the bottlenecks are not the equipment. Okay, the bottleneck is the information management. I mean, how we are managing the operation. Okay, and when you have a, a situation like that, I mean, you are working with paper, have paper everywhere, and you're trying to make a decision, but you have a report in your hands telling you how was the production yesterday. So you make a decision today to address an issue that happened yesterday. But the issue that's happening right now, you're gonna only be able to see tomorrow. Okay, so you're always one day behind. Okay, so if that's your problem, and we believe that's the problem in most of the factories, you can start with a very small MES, a very small tillage project. Okay, that is a project that we can run in a couple of weeks. That it will be very cheap in comparison to an automation project. Okay, and you're gonna see value in a matter of weeks. Okay, so really depends. Okay, so um, for example, uh, if you are running a continuous process that's very intensive, that non-stop, and you have one or two SKUs, okay, so we have minor setup. It's your production is very steady and continuous. Okay, in this case, I would recommend invest in automation. Okay, because we have minor changes. It's flat. Okay, it's continuous. But that's not what we see in many of the customers we go, because they have 20, 40, 100 SKUs, and each SKUs means more setups, more quality checks, more decisions, okay, and more business rules. Okay, so if that's the case, I would recommend a solution like Tility to address all the complexity and orchestrate your operation. So really depends on where we are.
Yeah, I think
Is it
that's
clear?
correct actually. Yeah,
Yeah.
that's
Yes,
very
yes. Thank you so much. Thank you so much.
Yeah.
yeah.
Thank you for the question.
Anybody would like to? So I think Aditya has put a link in the chat box. If you want to join a community, we have created a community on for smart manufacturing for enthusiasts. So if you want to know the latest updates on smart manufacturing, if you want to join, you can just click on the link in the chat box and join our WhatsApp community. I think Mr. DK wants to say something. Please go ahead.
Yeah, it's a very amazing session. I would like to say thanks to Mr. Castro and Nitalji. Actually, I joined from the China basically. So we
Oh,
have yeah.
okay,
So
okay. We have East and
we
West
have
also.
so lots of technology upgrades I'm seeing here. Yeah, actually, we have manufacturing unit here. We use a MES
Mhm,
and some IoTs we have. But
mhm.
like my question to Mr. Castro is, what kind of security, like security threats, considering like IoTs and AIs, we want to implement some AIs and IoTs in our factory, like a Smart 4.0. So what kind of the security threats in future going in implementation of this particular, yeah, like right now some learning models like bots and all are available, but we are still finding some kind of threats to
Yeah,
using. Yeah. So I just want to know about it. Yeah.
yeah. There is risk everywhere, right? So, I mean, if you're running a solution on premise, okay, or if you're running a solution on cloud, you may have risks both ways. Um, uh, let's think that the business is already running on cloud. I mean, most of the business they have bank applications, and they are managing their money in cloud solutions. Okay, eventually they are managing emails on cloud solutions. That's very common as well. Okay, uh, so the business is already running on cloud. Okay, and I think that most of the strategic informations they are already being stored on cloud solutions. Okay. The factory or the operational level is one more important part of the business that is moving to cloud. That's my view. But we are already on cloud. I mean, um, and we have risks everywhere. That's true. Okay, and we have layers of security. So when we think about cybersecurity, I'm not an expert on that, so we can bring our we can eventually have a second round, and I could bring my expert here to talk about cybersecurity. But we have layers of cybersecurity. Okay, so for example, nowadays utility is approved by FDA, okay, which is a very, very rigid and strict regulatory uh, requirements to approve. So we have uh, backups for everything. We have encryptography end to end. We have control of access. We have different profiles. So we meet all the requirements of FDA, okay, regarding cybersecurity and control of information, okay. Uh, and that's one level. That's one good level that we have achieved, okay. And the next level, which is a little bit harder to get, is the defense level, okay. So even in the defense business, there is a possibility to run on cloud. Okay, they will run on premise, but even in the defense, there is a possibility to be on a cloud level. Okay, and there is and to do that, we need to add more layers of security. Okay, so this can be done. Okay, this means more and more investment, more and more firewalls and eventually a dedicated cloud for that very specific customer. So that's possible. Of course, there's a cost for that, but of course, security is a mutual risk. I mean, we have our best practices here, and we follow it, and we are audited by AWS, and we are audited by FDA, and we can guarantee that we are doing that. But also, the user is co-responsible for the security of the solution. So if you have a device with the app and you leave this device in your supermarket, whoever find that device will have access to your apps. Okay, and eventually utility may be an app that is the guy will be able to see something in the shop floor. But I mean, uh, that information may be very pointless because as as we have control several level of access inside utility, if the operator lose the mobile with a utility app, that guy will have access to a very specific tasks and no reports and no dashboards and so on. So he will have a very specific questions to see uh, and nothing else. So it's equivalent to losing a quality checklist. So
Yeah, got it.
uh, there is a risk, okay, but I would prefer to have the cybersecurity being managed by uh, a cloud provider like Microsoft or AWS. That is a big company that is doing that as part of the core business, and they are doing that every day with the best guys in the world. Then having my security being managed by my local IT department that eventually doesn't have all the resources enough, they are not qualified enough, or they are not experts on cybersecurity. So it's a decision. I mean, do you want to outsource your cybersecurity to an expert provider like AWS, or do you want to do that in-house with your local IT department?
Yeah,
Okay.
sure.
Thank you. Thank you. Anybody else? We can take one last question and then we can wrap up. Okay, I think we have a very good audience today. We have from China, we have from Brazil, India, we have Mr. Vimal Shah joining from Africa also. So thank you, everybody. Yeah. Vimal bhai, you have any question?
No, Nital, thank you very much for
Thank
the
you.
opportunity to be here. It's a great pleasure to
Yeah.
connect with you and our
Thank you.
colleagues from India. And also,
Yeah.
well, we have, as you said, we have people from everywhere in the world. So I suppose that will be the first session of many that we can do together. And it was a great pleasure to be here with everyone. I hope you have liked it. And if you want to talk more about that, we can schedule a next section. And
Yes.
I believe you are going to share this material with everyone, right? So you have my
Yeah.
mail, you know where to find me.
Yeah. Yeah. So you can also put that in your chat box so people can find your email.
Okay,
And
I'll do that.
I request also to, if you want, you can also connect with us. We can also provide you the presentation material. And also this session we will be putting on YouTube, and we will also share the link. I hope that is okay, Bill.
Sure. The
Yeah,
material
thank you.
is public. You can share it. I'm just writing my email here for everyone. Okay, good to go. Okay, so thank you very
Okay,
much.
thank you. Thank you.
Stay blessed, everyone. Vanakkam,
Thank you. Vanakkam. Thank you.
and,
Thank
Yeah,
you,
and have a great
Bill.
Saturday.
yeah.
Yeah,
Shisha,
thank
thank
Thank you,
you.
you.
sir.
Bye bye.